Hey, hello guys, welcome back to my channel. So today we are back with another video. As I promised you, I will make a part 2 on chemical reactions and equations, first chapter of science class 10. So let's begin, and this is the part 2. Let's go ahead and without wasting any time. So hey, welcome back. Get ready. So let's go ahead. So topics we will cover today will be chemical equation, balanced chemical equation, unbalanced chemical equation, and the characteristics of chemical equation. So these are really easy topics to remember, and this balanced chemical equation is really easy. Let's go ahead and let's begin. So this must be you, right? Oh, nice. Okay. So class 10, chemical reactions and equations, chemical equation. So let's first know the definition of chemical equation. So a symbolic representation that uses symbols and formulae instead of words to represent a chemical reaction. As we had studied in the last video, what is chemical reactions when two molecules combine to form a new substance. Here also there is its same, a symbolic representation that uses symbols and formula instead of words to represent a chemical reaction. Now let me tell you this in a short way. It's a way to chemical reaction. Understand? Okay, can you understand that? It is just a way to chemical reaction. So let's go ahead. It also reflects the physical state. So remember this point. Sorry, I have fever. Ignore it. It also reflects the physical state. Remember, in exam, if this question comes from 3 marks that define chemical equation, you can write that and give an example. I'm going to show you example right now. So these are the example of chemical equation. So magnesium plus oxygen gas. We know that magnesium is a solid, oxygen is a gas, and magnesium oxide is white powder, which is solid. So this is what we get. Example, it's just an example. You can make any example of that. Now you can see this. Now I'm giving you a hint what is our next topic. Now so you have already learnt about chemical equation. Now you will learn what is the next topic, and the next topic, I think you shall get some hint from this picture. Yes, I think you are right. Let's go ahead, and it is balanced chemical equation. So let's see. Yes, so balanced chemical equation. So the definition of balanced chemical equation is a chemical equation in which the number of atoms of each element on the reactant side is equal to the product side. So here we can see that. So a chemical equation in which the number of atoms of each element on the reactant side is equal to the product side. It is that easy. As we studied in the last video about reactants and products, that reactants are always written on the left hand side, products are always written on the right hand side. So only here it is just saying that the left hand side is equal to the right hand side. LHS equals to RHS. It is just like reactants is equals to the products. So let's see in a short way what we can call this. So see, and here it comes. In short, we can call it mass of reactants is equals to mass of products. It is that easy. We had learned in the last video that what are reactants and products. Reactants are the the things which are used in a reaction, which take part in a reaction, in a chemical reaction. They are known as reactants. And products are the newly things formed from a chemical reaction. So this is that easy to understand. In short, we can just say it, mass of reactants is equals to mass of products. So let's go ahead. Example. So this is an easy example. I always give this example because it is really easy to understand. So magnesium plus oxygen gives rise to magnesium oxide. So here we can see that magnesium has the coefficient 2 over here. And sorry, Yes, so as I told you, I'm having a bit of cough, that's why I'm coughing a bit. Just ignore that. I will pause the video at that time. I will explain the whole part again. So, as I told you, this is magnesium has the coefficient 2 over this side, and oxygen also has 2. But here you can see that only magnesium oxide MgO is formed. So you have to also, I think I have not added about hit and trial method. It's a really easy method to understand. Actually, what we do, we have to take the same coefficients of both the elements. For example, here you can see magnesium is 1, and here you can see oxygen is 2. So it is an unbalanced chemical equation. We will have to balance it. To balance it, we will add a coefficient 2 behind magnesium, and also a coefficient 2 behind magnesium oxide, so that it can be balanced. So you can see, if we add 2 behind magnesium, we get 2 magnesium elements, and here there are already 2 oxygen elements, and here 2 magnesium oxide. So here 2 will multiply by magnesium and 2 will also multiply by oxygen. So we can also get 2 magnesium, here also 2 oxygen, here also elements, and here also 2 magnesium and 2 oxygen. It is that easy. We just have to see the number of the number of coefficient is same on both the sides. So let's go ahead and see another example for the same thing. So let's go ahead. So you can see here, hydrogen plus oxygen gives rise to H2O. You can see that. But here what it is showing, that hydrogen is 2, oxygen is 2. But it only gives rise to H2O, where only hydrogen is 2 and oxygen is 1. So to make oxygen 1, we will have to add a 2 on this side on hydrogen's coefficient. We will have to add a 2 over this side and a 2 behind hydrogen coefficient again. So you can see hydrogen will be 4. Here also hydrogen will be 4. Oxygen will be 2. Here also oxygen will be 2. This is an easy method that we have to just balance the numbers. For if we are having 4 here, then we shall have 4. Because as in the definition, mass of reactants is always equal to mass of products. LHS is always equal to RHS. So hydrogen shall be same on this side also and on this side also, and oxygen is also same. Hence, this chemical equation is balanced. So let's go ahead. Okay, let's go ahead. So our next topic is, this is one more example about that, only the same thing. Zinc, you can see here Zn plus HCl gives rise to ZnCl2 plus 2H. This is also, here also you can see zinc is 1 this side and 1 this side. Hydrogen you can see over here, this H is 2 this side and only 1 this side. So we added 2 over here. So to make it balance. And chlorine is already 2 on this side and this side. So I think till now you must have understood the method, that how to balance a chemical equation. So let's go to our next topic, which is unbalanced chemical equation. Let's go. So see, here is our unbalanced chemical equation. Now please listen a bit nicely, because this is most asked thing in exam. So let's read the definition first. If the numbers of atoms of each element on the reactant side is not equal to the product side, then the chemical equation is called unbalanced chemical equation. It is easy. It's just the opposite of balanced chemical equation, you must have noticed. Because you can see, balanced chemical equation was mass of product is equals to mass of reactant. LH is equals to RHS. But here you can see, mass of product is not equal to mass of reactant. In short, mass of reactants is not equal to mass of products. It is just the opposite. You can see this figure over here. In above figure we had seen that it was balanced, but here we can see it's not balanced. So let's see some examples of unbalanced chemical equation. Examples of unbalanced chemical equation. Example, H2 plus O2, H2O. Here you can see, as I showed you ahead up, that we had made it 2H2O, but here we will only make it H2 plus O2, H2O. Okay. Next example. So you can see magnesium plus oxygen, magnesium oxide. Here oxygen is 2, but here it is not 2. Therefore, it is an unbalanced chemical equation. We had studied about it earlier up, that the same thing. So we can see that here the number of atoms and elements are not same. For example, on hydrogen side you can see only there are 2 atoms, but this side also there is 2 atoms, but you can see on oxygen only 2 are here, but only 1 is over here, which is a big mystery. So magnesium, this magnesium is also 1. Here also it is 1, but oxygen is 2. But here it is not 2. Therefore, it is an unbalanced chemical equation. And I always give these examples because it's a really easy example for you to understand. So, let's go ahead. Okay, let's go ahead. Next is our next topic is characteristics of chemical equations. So, let's see our first topic, first point of this. Chemical equation provides the name of various reactants and products of a chemical reaction. You must be seeing here chemical equation provides the name of various reactants and products of a chemical reaction. As I had told you that chemical equation is a way to chemical reaction. And here you can see that chemical equation provides the names of various reactants and products of a chemical reaction. Now let's go to our next point, which is, first let's see some example on this side. Yeah, so here is our second point. I think there are, in the next slide there must be examples. Okay, so chemical equation gives us the number of atoms and oblique or molecules of the reactants and the products of a chemical reaction. So you can see the chemical equation gives us the number of atoms or molecules, atoms, elements and molecules of the reactants and the products. Reactants, you remember LHS, RHS, left hand side, right hand side, they both are. So that only, the reactants and products of a chemical reaction. So it is just saying that chemical equation gives us the number of atoms and oblique or molecules of the reactants and the product of a chemical reaction. Let's go ahead to the third point. Yes, it gives relative number of moles. So I just told you up the coefficients I was saying, it was actually the moles. It gives the relative number of moles of the reactant and the products. Okay, it gives us the relative number of moles of the reactant and the products. So let's go ahead to the next point. And the next point is, it gives the relative amount by mass of the reactants and the product. So up we had seen moles and mass. There's a huge difference. It gives the relative number of moles. Okay, and it gives the relative amount by mass of the reactants and the products. Now, fifth point states that it also provides information about the relative volume of gaseous reactant and products. And for example, now let's see an example. Calcium carbonate, when calcium carbonate is heated, it gives a CaO plus carbon dioxide. Okay, calcium oxide plus carbon dioxide. I just told you up. You will learn about this further, that what is this type of the reaction called. Actually, it is called decomposition reaction, which you will run ahead in the next video. Now we will discuss this because example on this. So let's go to our last topic. See, first of all, this side it is a solid CaCO3, and when it is heated it turns to CaO, which is a solid again, and CO2, carbon dioxide, which is a gas. So let's go ahead to our last topic, which is none